Road to Olympiad.
Welcome to RTO. Consider the following problem. How many positive integer x less than 4032 are there such that x squared minus 20 is divisible by 16 and x squared minus 16 is divisible by 20? Today, again we are having problem on divisibility on number. How are we going to make sure a number is divisible by 16 and 20 respectively? We'll show one way to do so later. Pause the video if you like to give this problem a try, and when you are ready, keep watching to learn how to solve it. To solve this problem, we start by looking at the condition x squared minus 20 is divisible by 16. Since 20 leaves a remainder of 4 when divided by 16, it is equivalent for us to consider that x squared minus 4 is divisible by 16. Notice that we can factorize x squared minus 4 as x minus 2 times x plus 2, and in order for it to be divisible by 16, we need x to be equal to 4k plus 2, where k is an integer. We can easily check that none of 4k, 4k plus 1, nor 4k plus 3 will make it divisible by 16. For x squared minus 16 to be divisible by 20, we need it to be divisible by both 4 and 5. So, we have another two conditions to check on. In order to make x squared minus 16 divisible by 4, the result we obtained just now, which is x is equal to 4k plus 2, is sufficient. So, we only need to consider the case where x squared minus 16 is divisible by 5. Notice again that we can factorize x squared minus 16 as x minus 4 times x plus 4. And in order to make it divisible by 5, we need to have x is equal to 5n plus or minus 4 for some integer n. So now we are going to consider the two situations separately by substitute them into x is equal to 4k plus 2. For 4k plus 2 is equal to 5n plus 4, we have 4k is equal to 5n plus 2, which can be written as 4k is equal to 5 times n minus 2 plus 10 plus 2, or simply 5 times n minus 2 plus 12. Since all the terms here are divisible by 4, we must have n minus 2 is a multiple of 4. That is, we can let n minus 2 be equal to 4n1 for some integer n1. And this will simplify the equation to 4k is equal to 20n1 plus 12. Dividing by 4, we have k is equal to 5n1 plus 3, and substituting this back to x is equal to 4k plus 2, we have x is equal to 20n1 plus 12 plus 2, which is equal to 20n1 plus 14. Similarly, for 4k plus 2 is equal to 5n minus 4, we can argue in a pretty similar way as follows. And we'll obtain x is equal to 20 and 2 plus 6. This is to say that for every 20 integers, we can find two integers that satisfy both the given condition. And thus, we will have 402 integers satisfying the conditions for integers up to 4020, because there will be 201 group of 20 integers in this case. As for those integers between 4020 to 4032, there's only one more integer satisfying the conditions, which is 4026, as the next number which satisfies the conditions is 4034, which is not in the given range. Therefore, there are a total of 402 plus 1, which is 403 integers satisfy the given conditions. And this marks the end of the solution. Post in the comment below if you have any thought on the video, and if you haven't subscribed yet, consider subscribing. This will really help us out. Anyway, see you in the next video. Thank you.